Okay, section 7.2, which is called right triangle trigonometry. I always like to refer to this student as probably the single most important section of the geometry curriculum. It's something that you will use in every math class moving forward and in a lot of professions as well. Before we can learn anything new today, we have to make sure our calculators are in the correct mode. So what I mean by that is they have to be in degree mode. So everyone take your calculator right now and type in this in your calculator. So the sign button should be right above the 7 area in your calculator screen. It should be SIN, and then hit 37 and hit enter and see what you get back. You should be getting 0.6018 or 0.602. If you're not getting that, go to the mode button in your calculator and change it from radians to degrees and then try again until you get that. Once you got that, let's move on to what we're going to learn in this section. So here we have a triangle, a right triangle. Some methods we've used this year to solve for missing right sides of right triangles include the Pythagorean theorem, special right triangles like 36, 90, and 45, 45, 90, but none of those are going to apply here. Okay, well, you can't use Pythagorean theorem because you have to know two sides in order to do that. And we can't use special right triangles because it's simply not a special right triangle. So the question is then, how do we solve this for x? And it involves what we learned in the last section, right triangle trigonometry. So if you remember from last section, we learned sine, cosine, tangent, secant, cosecant, and cotangent. We're not going to use all 6 in this section. We're only going to use sine, cosine, or tangent. So it's our job to figure out which of those 3 would apply to this triangle. So how do we do that? What we're going to do is we're going to look at the angle. So looking at the angle, you want to ask yourself about 18 and x. Are those sides opposite legs to 34, adjacent legs to 34, or hypotenuses of the triangle? Well, x is clearly the hypotenuse of the triangle, so we have a hypotenuse. And then 18 is the opposite leg to 34. So you should be thinking, all right, I know I'm going to use the opposite leg and the hypotenuse. And then you want to ask yourself, which of those 3 functions relate the opposite leg to the hypotenuse? And if you remember, sohcahtoa, which one is opposite leg and hypotenuse? That would be so. So we're going to use sine for this problem. So the next thing you got to figure out is, how do I set up my equation? So you always start by writing the function down that you're going to use. We're going to use sine. We're going to use the abbreviation SIN. What follows that is always the angle. So in this case, the angle is 34. What follows the angle is always an equal sign. And then on the right side of our equation, we're going to set up a fraction. Opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. In this case, opposite over hypotenuse. The opposite leg is 18, the hypotenuse is x, and there we have our equation. Okay, important note here. Sine and 34 are best friends. They are inseparable. They cannot go anywhere without each other. Okay? So, don't let them leave each other's sides. To solve this, what we're going to do is we're going to start by multiplying both sides by x. So that gives me on the left side x sine 34. On the right side, these x's cancel out, and I'm left with 18. And then I'm going to divide both sides by sine 34 because, again, they're best friends. They don't go anywhere without each other. And we're trying to get x by itself. So now these cancel out, and we're left with x equals 18 over sine 34. And that's our answer, 18 over sine 34. Now we can get an approximation by typing that into our calculator. So 18 divided by, hit the sine button, 34. And our approximate answer here is 32.19. And that's pretty much what we're going to be doing for all the problems in this section. Let's take a look at another one. So here we look at 34 again. 34 is the angle. So looking at 34, 22 is clearly the hypotenuse of this triangle. X is the adjacent leg to 34. So which one uses adjacent and hypotenuse? That would be ca. So we're using cosine. Once we figure that out, now we can set up our equation. Our equation is our trig function, abbreviation, followed by our angle, followed by an equal sign, equals adjacent leg over hypotenuse. Okay, so this time, our variable's in a numerator. That's actually going to be a little bit easier to solve. Okay? So we're going to multiply both sides by 22. And we get 22 cosine 34 equals x. And that's your answer for x. Type in 22 cosine 34. We get 18.24 as our answer for x. Number 4, we're going to look at the angle again, 54. X is the opposite leg to 54. 9 is the adjacent leg to 54. Which one uses opposite and adjacent? That would be TOA, or tangent. So it's tangent of the angle 54 equals the opposite leg, which is x, over the adjacent leg, which is 9. Multiplying both sides by 9, we get 9 tangent 54 equals x. Type that in your calculator, we get 12.387 or 12.39. All right, so next one. Okay, so here's 54 down here. We have the opposite leg to 54 and the adjacent leg to 54, not the hypotenuse. So once again, this is going to be tangent, or TOA. So we set up our equation tan 54 equals the opposite leg over the adjacent leg, so 17 over x. So now, again, we have our variable in the denominator here, so we're going to start by multiplying both sides by x, and that will give me x tangent 54 equals 17. And then dividing both sides by tangent 54. We get 17 over tangent 54. The next one's a word problem, so we have to draw our own picture here. A ladder is leaning against a house. I don't need anything perfect for this picture, just Here's the ground. Here's my house. And we have a ladder leaning against that house. The angle between the ground and the ladder, so here's the ground, here's the ladder, the angle between them is 72 degrees. The base of the ladder is 6 feet from the house. Here's the base of the ladder, here's the base of the house, that's 6 feet. How long is the ladder? So we want to know this length right here. So we have, looking at 72, we know this is a right angle here. We have the hypotenuse of the triangle, and we have the adjacent leg. So we know this is going to be cosine. So we write cosine 72 equals 6 over x. Multiplying both sides by x, we get x cosine 72 equals 6. And then dividing by cosine 72, we get x equals 6 over cosine 72. For our answer, we can type that into our calculator. This is approximately 19.42. Number 7, a balloon is tied to the ground. The wind is blowing the balloon, so the angle between the string and the balloon and the ground is 56 degrees. The string is 8 feet long. How high off the ground is the balloon? All right, so we have the ground here. And we have a balloon that's tied to the ground, blowing in the wind here. And here's our right triangle. The angle between the string and the ground is 56 degrees. The string is 8 feet long. How high off the ground is the balloon? So we're looking for that one right there. So we have the opposite leg and the hypotenuse. This is going to be sine. Sine of 56 equals the opposite leg over the hypotenuse. Multiply both sides by 8. And we get 8 sine 56 equals x. We can type that into our calculator. And x is approximately 6.63. All right, now we can learn the second part of this section as well here is trying to find the angles. So we can use trig to do that as well. Looking at this picture, what equation would you set up for solving x? So here's the angle. Looking at the angle, 13 is the hypotenuse, and 6 is the adjacent leg to x. So adjacent leg and hypotenuse, we're going to use cosine. So our equation would be cosine, then following the trig function is the angle. The angle here is x equals the adjacent leg over the hypotenuse. So now the question is, how do we solve this? Well, let's come back to that. How would you solve these equations? Well, to solve the first one, since they're adding, we would subtract. To solve the second one, since they're multiplying, we would divide. And to solve the third one, since it's a squared, we would take the square root. Okay, these operations are called inverse operations. I can't spell operations today. Okay, so the question is now, what is the inverse of the operations we're doing right now? Remember, sine, cosine, and tangent are just operations. So if you look above on your calculator, you look above sine, cosine, and tangent, you see sine inverse, cosine inverse, and tangent inverse. It's a little sine, cosine, tangent with a negative first power on it. So that's what we're going to do. We're going to take the inverse of both sides. Okay, so how do we do that? We're going to write cosine inverse over here and cosine inverse over here. So on the left side, we have cosine inverse of cosine, and those cancel each other out. And we're left with just x. And the right side, we have cosine inverse of 6 over 13. And that is our answer, and that's what we could type into our calculator. Cosine inverse, so hit second cosine, 6 over 13. And you should be getting 62.51 degrees. All right, so back to this here. Sine is an operation, and we need an inverse operation to undo sine. That operation is sine inverse. Same thing with cosine and cosine inverse, and tangent inverse. All right, so here's a couple more practice problems we're going to do. First one, we have angle x. 7 is the hypotenuse. 5 is the opposite side. So opposite and hypotenuse would be sine. So we're talking about sine of the angle equals opposite over hypotenuse. Taking the sine inverse of both sides, we get this. Type that in your calculator, you should get 45.58 degrees. Looking at B. Looking at x here, 11 is the opposite leg to x, 13 is the adjacent leg to x, so that should be tangent. Tangent of x equals opposite over adjacent. Take the tangent inverse of both sides. Type that into your calculator. And we should be getting x is approximately 40.24 degrees. Couple more practice problems here. For part C, we have an adjacent leg and a hypotenuse. That's cosine. So cosine of x equals 6 over 13. So x equals the cosine inverse, 6 over 13. So x is approximately 62.51 degrees. And part D here, we have x, and then opposite leg and hypotenuse. So that would be the sine of x equals opposite leg over hypotenuse. So x equals the sine inverse of 4 over 10. So x is approximately 23.58. Okay, another word problem here. We have San Francisco is famous for its steep streets. The steepness of a road is expressed as a percent grade. Filbert Street, which is the steepest street in San Francisco, has a 31.5% grade. This means the road rises 31.5 feet over a horizontal distance of 100 feet. Find the angle it creates by the street and the horizontal. Okay, here's my horizontal. And here's the street. And here's the rest of my right triangle. The grading means it has a 31.5 foot rise over a 100 foot horizontal, and we want to know the angle created by the street and the horizontal. So that X right there. So it's the opposite leg and the adjacent leg. This one is going to be tangent. Tangent of X equals 31.5 over 100. So therefore, X equals the tangent inverse of 31.5 over 100. X is approximately 17.48 degrees. So if you're driving on Filbert Street, you're driving up a street at 17.48 degrees. Example 10, a 6-meter long ladder leans against the building. The ladder reaches 4 meters up the building. What angle does the ladder make with the ground? So here's the ground. Here's the building. Here's my ladder. The ladder is 6 meters long. It reaches 4 meters up the building here. And you want to know what angle the ladder makes with the ground. So we have the opposite leg to X and the hypotenuse. So that would be sine. Sine of X equals opposite over hypotenuse. So X equals sine inverse of 4 over 6, which is 41.81 degrees. One more. A restaurant needs to build a wheelchair ramp for its customers. The angle created by the ramp on the ground is recommended to be 5 degrees. The vertical distance from the sidewalk to the front door is 2 feet. How long will the ramp be? All right, so here's our ground again. Okay, well, here's our building, and we can say the front door is right here. The vertical distance is 2. The recommended angle is 5 degrees. We want to know how long the ramp will be. So this is what we're looking for here. All right, so this is a little curveball here. We're not doing angles anymore. We're going back to what we did earlier today. We have the opposite leg and the hypotenuse. That's sine. So sine of 5 equals opposite leg over hypotenuse. Multiply both sides by X. We get X sine 5 equals 2. Divide by sine of 5. We get X equals 2 over sine 5. Type that in your calculator. And our ramp should be 22.95 feet. All right, there are 7 practice problems I would like you to try. You can pause the video, and when you come back, you can check your answers on these 7 problems. Okay, you can see the answers for the first 4 here. Pause the video if you need to take a longer look at it. And the answers to the last 3. And that will do it for our lesson on 7-2 right triangle trigonometry.